Okay, we're continuing our study of classes, the way Java constructs classes, and well, they're basically two, or you could think of three pieces to a class: the instance variables, or the state or data, the methods or behavior or interface, and the constructors, which are a type of method, but they're a special type of method. And a lot of this we've kind of touched on, but it bears repeating. So we're going to talk about a little bit about constructors, what's going on with that, constructor overloading, and basically what happens when you go to try to create an object. Then we're going to circle back and notice that in the example, there are some times when you want to constrain your possible variables and what to do about it. So we're going to have a little look ahead into something called exceptions there, and review again what shadowing is about. I've mentioned that a couple times, but it's still important. And about every couple years, it kind of bites me in something. So it's something that comes up. Then we've also a lot of this is review, and then I want to talk about JavaDoc, which is actually a very important thing. So after this, define a constructor, and this idea of a master constructor, define multiple constructors and what it takes to do that, and to be able to understand the calling sequence in constructors. I'll show you how that happens, and in the process also we'll look at how to do debugging in NetBeans. Have you done debugging in NetBeans before? No. Okay. So that'll be new. And then come back to this idea of constraining the values. In other words, and that's touches on two pieces that I've talked about. One is this idea that the optimal number of places where a variable changes value is 1. That's the optimal number of places. It's not always possible, but it's the ideal. And one of the things that you can do for that is, if there's that one place, and typically it's a setter, is that if there are certain values of that variable that are not legitimate, then that's the place where you can correct it. And the time to correct it is when you're actually instantiating the object. In other words, if you instantiate an object and it has garbage data, then you can be running the program and it's the garbage in, garbage out idea. So, in particular, in our example, there are some variables that can't be like negative. So how do we do that? In Java, there's no concept of a positive integer. Now, if there were a positive integer type, for example, then we could use that, and the compiler would fix that for us. That doesn't exist. I don't know of a language in which there is that idea. That would be nice. It would save a lot of headaches. The thing about data, and just sort of peeking way ahead into kind of more production type of code, is that where does that data come from? In this class, most of, later in the course, we'll kind of talk about reading in data from a file, and that's where data typically comes from. But the thing is that all data is really just strings. All data is just strings, and that includes every piece of your program, including the source code. The source code that you write is just a bunch of long strings. And what the compiler and does is it turns that string, in Java's case, into bytecodes. In the case of an interpreted language, it turns each of those statement strings into an executable instruction on the computer. But everything is strings. So if I read a string, we've already seen some examples of this with the scanner. If scanner is expecting an int, and you give it a string, then it blows up. Why? Because I want a number, but you gave me this other thing that's not a number. So given that the data are all strings, that means that some of it's going to be good and some of it's not so good. In this case, even if we give it an integer, if it's not the right type of integer, if it's not the right value of integer, then we want to be able to blow it up before we even get started. So, and then we'll circle back to the shadow thing. That bears emphasis. And then visibility modifiers, we've kind of seen that and want to kind of just really nail that, and then we'll move on to JavaDoc. So, constructors, and this was something that Java, they didn't invent that. Almost everything in Java they kind of stole from somewhere else, just that's the way to. But at least at the time, in C++, which was the dominant object-oriented language at the time, they had the notion of classes, but the class didn't have to have a constructor. And one of the things that the Java developers did was they really they studied a lot of different languages, and they kind of extracted what they thought were the lessons learned from them. And one of the lessons learned from C++ was that you should always have a constructor. Always. So even though the language didn't require it, it turned out that was a best practice. And so Java took a lot of the best practices and made them required. Just sort of an FYI, and this is a little bit of ancient history, but there was this big controversy over the goto statement. Okay, what was goto? You probably have never even seen it. And that's a good thing. But goto was when in the original code, where you just kind of start processing line after line after line. In the early languages, like Fortran, there was the goto statement, and it just said, you hit this thing, it said go to this line. So you could go to an arbitrary place in your program with this statement, and that led to what they called spaghetti code. So it's like it's what here, and it kind of drove people crazy. So, and up until Java, every language had the goto statement because that's kind of what people did and liked to do. Java looked at that. They decided, yes, the goto is bad. In fact, there were articles in computer science journals about goto is terrible. Never use it. So Java prevented the use of goto, and the fact that you've never even seen a goto is evidence that that is kind of continued. So that was kind of the good thing. So if you don't write a constructor, Java will write one for you. So we've looked at that a little bit. If you write a constructor, though, then Java doesn't add theirs. So that's just something to understand. And as we've seen, a class can have more than one constructor, and many times that's a good idea. But you have to have a different signature. So this word signature means in either a constructor or a method is the type of arguments that you have. That's the signature. So if there are no arguments, the signature is zero argument. If there's a string, the signature is string. If the constructor or the method requires a string, an integer, and a double, the signature is string, int, double. Okay, so and then we've used this scanner class, and these are all the constructors in the scanner class. So we have used, the one we used when we used system_in was actually this one, because system_in is something called an input stream. But as you can see, there are lots of all different ones. We can give it oops. There's a class called file. What do you suppose an objective type file refers to? Something on your file system. That's one of the ways that we interact with the file system. So if I have one of these file objects, I can just kind of give it to it. And in fact, we can even, if we just have the name of something like a file, we can give it to it. And that's a little bit, I discourage using that, and I don't like to use that. Why? Because with these file objects, we can do things like verify whether it exists or not. So for example, if I'm reading a file and it doesn't exist, then all kinds of bad things are going to happen. With a file object, I can check, if you exist, I'm going to read you from it. If it doesn't exist, say the user, hey, this doesn't exist. And things like readable byte channel, paths, or like these paths and others, and even input streams. It turns out the system in was one example for that, but that input stream can be from anywhere. We can actually open a socket and get an input stream from that. And so we can use Scanner to do like screen scraping, things like that. But the point here is that these are all the different constructors. And so if I want to create a scanner, I have lots of different options depending on what kind of thing I have to feed it. And when you're writing a class, then that's something to consider. That is, what are all the different things that the user might want to give you? And you want to be user-friendly, especially if you're going to be the user of it. And so if you have a lot of many instance variables, then you typically want to have a master constructor that has all of the different possibilities. But that might be a bit too much. Like there will be circumstances in which there might be default values, and if they're a user, you might want to have some, specify some of the inputs, but then accept all the rest defaults. And so the way to implement that is to have your master constructor and have other constructors that have some, but not all of the variables, but then populate them with the default values. And we actually have an example of that in what we did. So, flow of control. The first call is always a call to super or this. And if it's not added, then Java will add a call to super with an empty string. The fact that Java does that, it's important to kind of put a pin in this, because when we start writing classes that have, when we start doing subclassing, which is in a little while, then what sometimes happens when we're writing a subclass, we get confusing messages that have, we say that the error message is referring to things that we didn't write. It says, oh, hey, you're doing this and it's wrong, and you say, but I didn't do that. Many times in that context, it's because Java under the hood was kind of writing its own constructor and then calling super, but then what do you do if the super constructor doesn't have a zero argument constructor? Then I'm trying to call a method with the wrong argument, the compiler gives you the red squiggly. So super invokes the constructor of the class's superclass, and then a call to this, and it's a call to again, I don't like the keyword this, but we're kind of stuck with it. Now the thing is that there has to be at least one call to super. So if all of the constructors call this, then it just kind of, you sort of get in an infinite loop. So let's sort of see that in action. So yesterday, got this? Okay. So here's this course class that we were working with, and I defined two constructors. Here's the master constructor, because we have a name, the number of days, and the price per person, at least for this version of the thing. And let's see this. Why is it doing that? Okay. Okay, two constructors. And here I've explicitly called super, just to emphasize that. I could leave, if I leave that out, if there's no call to super, Java's going to put it in for me. Okay, so, oops. Okay, but then here's the subconstructor. So supposing, for whatever reason, I'm content with the default. So the default is 10 days and 30,000, or whatever it is. And if I'm okay with that, then all I need to do is give it the name of the thing that I'm created. And what it will do is it will, by calling this, it makes sure that all the stuff in the constructor, in the master constructor, is going to happen. So how can we kind of really illustrate that? Well, let's let's create another one. Now what I've done here, notice what I've done. I've I've taken a variable that's already been declared to be of type course. I kind of instantiated it here, but then I said, oh, now I'm going to change that variable. So what's happened, just to kind of understand from the garbage collector's point of view. Oh, and this was the error one. This is why we're going to constrain it. So let's not kind of do that. Okay, so what's happened? But just as a by the by, here the course variable is referring to stuff in memory that's going to hold the information for this course object somewhere. And then here, now I've taken that variable and I've pointed it to another object, an entirely different object. So what has happened? What has happened to this object? Well, it's still around by the time I get here, but by the time my code hits this line, this object that I created up here has gone out of scope. It's still in there, but I can't reach it. There's no way. There is zero way. If I wanted down here to refer back to this object, I can't. It's gone. Or, I mean, it's there, but I can't find. I mean, I can't. So now in non-garbage collected languages like C++, this would be a memory leak. In other words, that memory that was being held there would stay there forever and I have no way to do anything with it, because in those languages I had to explicitly go and call what's called a destructor. I had to release that memory explicitly. And Java realized that, and that caused a lot of problems. Why? Because it's just too easy to do. In a large program, you got lots of objects. It's just too easy for an object to go out of scope. So in Java, what's going on is they have this garbage collector that's kind of always kind of sneaking around your program and peeking into stuff. And at this point, now if there were more things going on, at some point it would realize, oh, here's an object that has no references to it whatsoever, so I'm going to go in, I'm going to free up that space so it can be used for something else. Okay, now that isn't what the point of this was, but anyway, so, all right, so let's, just to illustrate what's going on with all the this and the super stuff, well, let's use the debugger. So how can we use the debugger? You know what a debugger is, right? You set breakpoints and then you go stepping through. So here's how we do it in Java. I can set a breakpoint by clicking on this little gray thing here, and it creates this, I don't know, kind of salmon-colored thing on my line. I can create as many of these as I want, and then now there are two ways to run the debugger. I can, and so what'll happen is it'll run to this point and then stop. So I can right-click and say debug file instead of run file, and it will go. And then when it hits green, that says that's where I'm at. And then now there are lots of cool things here. One is here's my core. Now this line has not been executed. So at this point, before I execute this line, this variable core still refers to this object that I've created up here. It hasn't done it yet. So the variables tab will show me all of everything that's going on. Here are the breakpoints, and I can even okay, another useful thing is what's called the call stack, and this will show the sequences of calls. Here there isn't one. We'll see what's going on with that later. Now, okay, so a couple ways to do this. I can kind of go to where where I'm calling it, and well, in this case, I'm calling a constructor, I can step into it. So you see up here, all of a sudden, this little control panel has popped up. So this stops the debugger, this pauses the debugger, this continues the debugger. I can step over expression. And in this case, I'm going to step into. So I'm going to step into the constructor, and that puts me right here. Okay, so I haven't executed it. And so I want to, now if I step over, it'll kind of go, but I want to step in. So it's called the constructor with the string argument. And now what happens when I call this? It's going to call the constructor, the master constructor in this case. Why? Because that's what I told it to do. Okay, so now I have the super. So what's going to happen when I step into super? Well, it's all of a sudden, and this is, the names just get really confusing, but what is this thing? When we talk about inheritance, we'll kind of get into this, but this is the granddaddy of all classes. So every class is some child or grandchild of this class called object. So it's a class called object. Maybe not the best name, but that's what they called it. Okay, so, and then notice it actually doesn't, well, in this case, here I have a constructor with 0 arguments and doesn't do anything. Okay, so, but that's what happens. And so if I step over that, then I've actually gone back to here, and now I buzz down, set all this, and then, well, here, let's look at the call stack here. So here we came from our main. Here was our this, and then this is where we actually are. So here this says line 26, that's where we called it from. So you see how the call stack gives us useful information. And then now we return from this call, we return from our constructor, and now we're down here, and then we're out. Okay, so you see how that goes. Okay, it bears repeating. So ideally, it's in some cases it isn't always possible, but that should be the default. That when you have a class, you have all your instance variables that need to be initialized, then have one constructor that initializes all of them, and then if there are default values, have other constructors that set some of the instance variables, and then have the others be default values, and have it always called a master constructor. Ideally, you only have one constructor that calls super. That's ideal. And everybody else calls this. Okay, so we saw this common ancestor, a class called object. Okay, and so for right now, our class is called to super invokes the objects constructor. But then again, once we start looking at inheritance and subclassing, then we can actually kind of go deeper into that. Won't do that now, but just put a pin in that. Okay, so just internal encapsulation. Even on the inside of a class, it's a good idea to use a setter when it's possible. So now in this case, I had a slightly different design from the book because I'll talk about why. So here, at least for these two instance variables, even within the class, it's usually a good idea when you're setting it to call the setter method. Okay. Now, why did I deviate from the book when it came to the name instance variables? And that's because in my from my perspective, the name is something that shouldn't be changed. It's like if you have a course called Java as a Second Language, that's the name of the class, and that's what it's going to be. And so if you have an instance variable that you don't want to change, then you can make it final. And if you make it final, then you can't have a setter. Now, you don't have to make it final, but if you don't have a setter, then it's essentially final, especially if it's private. Okay, so now let's talk about how we constrain the setters. So if a value doesn't meet some criterion, that is, in this case, say, for example, the price, we're going to assume has to be bigger than 0, because at least if we want our institution to not go out of business, then if somebody takes a class, then we take their money and not the other way around. So we don't pay you to take a class. So how do we do that? Well, now, as we've seen, we can't do that by itself. So what we have to do is something like this. We have to say, okay, if the price is bigger than 0, then we'll set it. Otherwise, we're going to do something, bad. And this is a little bit of a look ahead, because later we'll talk about what exceptions are. But the way that Java deals with these is something called exceptions. And one of the workhorses is there are actually a bazillion exceptions. The two that we will most often use are illegal argument exception, and the one you will most encounter is something called a null pointer exception. And so in other words, and then when we do this, have you dealt with exceptions? I know Python has exceptions, so you're familiar with that concept? Yes, and some not so much. Okay, so what this does is when by throwing this exception, we're actually stepping all the way out of constructing the object. It's saying, forget this. All right, so how do we do that? Well, okay, let's come back here. And let's find, I'll do it on set number of days. Okay, so, and there are a couple ways of doing this. Actually, what I actually prefer to do, rather than, is a slightly different style, is that first I'll instead of saying if it's good, I'll set it, otherwise I'll throw the exception. I start off by saying if it's bad, I'll throw the exception, and otherwise I'll set it. Glass half empty, glass half full, whatever you prefer. So what is if the number of days is less than 0, then I'm going to throw a new illegal argument exception. And as you can see, the illegal argument exception is a class that has 3 constructors, one of which is an empty one. Anyway, there are a number of different ways. Usually for something like this, I'll just use the string one. Now here's the thing, is that you want to be user-friendly, especially if you're the user. If you're running a program and it bombs, if you're doing anything, like if you're, on a web page, or if you're running Word or something, and you get an error, what do you as the user want? Yeah, you want to know what happened and why, and how much can you tell me about what went wrong so I can fix it? And so now, when you're writing it, that's what you should do. So what went wrong? So I'm going to say, here's what went wrong. Number of days has to be bigger than 0, and this is what you gave me. So the principle is you want to give the user as much information about what went wrong, what they gave you, and maybe what in this case, what went wrong tells you what to, say you have to be bigger than 0. You gave me something that wasn't. So how can we, and then now, how can we test that? Well, let's try giving it a negative value and see what happens. What happens is this. So exception, and again, here's the thing, number of days must be bigger than 0, and you gave it 50. And now, and then what's nice about NetBeans is this actually tells me exactly where that happened, but then it also gives me the call stack. So this was where it happened, this is where it got called from, and then this is where the whole thing started. Okay? And then notice that it kind of bombed out entirely. It just said, there's no point in continue, it's like I tried to instantiate an object, and the object failed to instantiate, and so if the situation is your program requires that object, then what's the point in even trying to run the program? So it just, hey. Now, there may be circumstances in which you might want to sort of continue, building building the objects to see what else might be going wrong. And then so what do you do with that? Well, what you do is you catch the exception and then deal with it. But we'll get into that when we deal with exceptions. And then here's the price. We'll do the same thing for the price. If price per person, price per person is less than 0, then throw new illegal argument exception. Let's say price per person and you gave me that. Okay, so let's now, so say, well, here we have two things that can go wrong. What's going to happen? Well, let's see. Okay, in this case, the number of days went wrong. Why? Because that's what we called first. So if I fix that, and then run it again, now I get the error on the other one. So if I have multiple exceptions that could be thrown, I have multiple bad data, it'll throw it on the first one. Okay. Now in the book he did it this way. You can do it either way. They're both equivalent. Again, and then notice also. Shadowing is something to consider as well. So and this is in constructors and setters. This is something that happens. Normally, it's not the best practice, but if it happens, that you have a local variable, or in this case, an argument, which is syntactically identical to a local variable, and it has the same name as an instance variable. The way to distinguish them is the instance variable is actually referred to as the object dot the variable, and in fact, everything in every object is referred to that way. It's just that when you're within the object, this is assumed. So if you leave it off, then in this case for an instance variable, then it will if I leave it off and I don't have this, then and I just leave it off, it'll refer to the instance variable. But in this case, price argument is shadowing the instance variable, and so if, to do the setting, I need to explicitly refer to it as this, and there's no ambiguity. And as we hopefully have seen in this case, notice the here we go. So NetBeans gives us a hint about that. So here, this dot number of days is in a different color than the argument. And just in general, instance variables are going to be in a different color in any decent IDE these days. And so if it is being shadowed, and I see a variable that's in black, then that should be a visual cue that something is going on here. In other words, these are two different variables. That's just something to beware of. Okay, so fully qualified name. We've seen examples of that. Okay, visibility modifiers. Okay. Very, and this is one of the things where when Java came onto the scene, they what they wanted to do is they wanted to convince mostly C and C++ programmers to switch to Java. Okay, so now how can you do that? How can you convince somebody to switch languages as their main developing thing? That's a pretty tall order, because there's a lot of, it's a big cost to say, okay, I'm going to stop doing it this way and I'm going to do it this other way. There better be a damn good reason. There better be a damn good benefit to doing that. And there was. The idea that Java would actually run everywhere exactly the same, that was one thing. Their superior object model to the way C++ did things, that was another. The fact that they used the automatic garbage collection, they had threading built in, they had the way that variables were passed was just infinitely simpler than what C and C++ did. In C++, you could pass by value, pass by copy of value, but, and Java said, forget all that, we're going to do it one way and one way only, and that makes it really simple. Okay. So for whatever reason, they had this sort of default modifier, like especially in C, there's no concept of private, public, whatever. Everything is just kind of unmodified. As you've seen in, like coming from Python, you don't see those type. The concept doesn't really exist. And so, to me, this was a little misguided, but they wanted programmers to feel comfortable, so they wanted the ability to not have to use these keywords. It was, in my opinion, a bit misguided, but that's, there are 4 visibility modifiers. So there's public and private. Those are the 2 main ones we will use. The third one is the so-called default, where there's no modifier, and that's something that you should never use. It's something the language allows, but you should never use. Just like public instance variables are a sin, but you're allowed to use it. And then there's something called protected. We're not going to use protected much this quarter. It turns out that in the simulation, the Java simulation models that we'll be looking at next quarter, if you take that class, protected turns out to be a useful concept there. So that will come into play then. But in this course, everything will be public or private and never default. So just watch out for that. So what is public? Public is visible from everywhere. Public is just like kind of, public is like, taking your social security number and posting it on your Instagram feed. Okay, so, and if that doesn't, if you don't like that, then maybe you can understand why instance variables should never be put out there. Okay, so public is, anybody that has access, and they say, don't worry about the class. If you have access to that object, you can basically see it. Private, now private is just like much more restrictive. In private, it's accessible only within the class itself and nowhere else. It's a basically locked up type. And that can be, when we get to inheritance, that can lead to a little bit of confusion. But we won't confuse things until we get there. Okay, the default one is it's within the class, but also throughout the package, and so it's something called package access, whatever. Not the best idea. And in protected, the main reason we want to use protected is because protected actually gives direct access to the subclasses. Okay, what's a subclass? Just put a pin in that. We'll kind of get to that. We won't be using protected this quarter, so that. Okay, and this diagram is something which is important. Okay, so we have variables and we have methods. Remember, the class consists of variables, instance variables, and methods. Public and private are the two main access modifiers we will be using. Public instance variable violates encapsulation. Remember, encapsulation is the idea that things are like literally in a capsule. And so if you take that capsule and you just kind of open it up and leave it to the world, then it's a violation of that. So this should never happen. And just in any class, now sometimes, especially, we use that refactor tool to generate setters and getters. Sometimes that can accidentally lead to public instance variables. You want to just always be on the lookout for that because that's the mortal sin of object-oriented design. Okay, so instance variables should always be private. Now methods can be, most methods are going to be public. Some might be private, and that depends on who their clients are. So a method that provides services to other clients, I mean, that's basically what we've referred to as the interface or behaviors, things that other objects can make you do. But sometimes just for the code being not too bad, you want to take a task and you don't want to expose it to the world, but you want to be able to kind of do it over here. And in that case, sometimes we'll have a private method, meaning we can call that method from within the class, but from nowhere else. Okay, finally, JavaDoc. So we've seen examples of JavaDoc. You notice that the NetBeans creates the class level JavaDoc by default and actually puts in a little tag for the author. Now what JavaDoc is, it's a slash and a star separated by a slash and two stars separated and then ended by a slash and a star. If there's a slash and a single star, that's just like a regular comment, and that's just for somebody reading the code. And then the other is the double slash, and that just is a comment for the rest of the line. What this JavaDoc tool does, the JavaDoc comments can be processed by the JavaDoc tool, and that produces these linked HTML pages. And we can also include some keywords such as author, version. Param is one you want to have in your methods that have an argument, and return for those that have a return type. So, for example, like in this case, the class level JavaDoc for this, which was generated using just this, and then I added what you want a comment about, okay, what is this class about? When you get into more production level things, you can also put in, here's how to use this. You know, if you look at the Java's JavaDoc for many of their classes, they have a very extensive, basically literally a documentation of that, where it's like a user manual almost for that class. Now, NetBeans is pretty good about this. So here's how I want to create it. If I want to create a JavaDoc for this, I'll just do the slash double slash, and I hit enter, and it just does all this for me. So here it read the fact that I have 3 parameters, and it gave me those. So I want to say something like instantiate a course with the given Stan create a course. And then you just want, if you've named your variables well, that's, they say it's misspelled, but they won't tell me what it is. Okay, so there's an example of it. Notice that the in the setters and getters, they actually set the param for the getter. They put a they put kind of a placeholder there. Now, if you've named your variable well, then you don't have to do a whole lot more. One of the more things that you ought to do is that if you're going to throw an exception, then there's also a throws and then this is if person, and then now this is HTML, so I can't use the I need to use something like that, basically the HTML tag for less than or equal to in this case. So I'm going to throw an illegal argument exception if the price per person is less than or equal to 0. And actually, probably I should make this less than. We're going to, and here, I'll do the same thing. I'll throws if number of days is less than or equal to 0. All right, now what does all that do? Let me undo this here. Now, if we right-click on our project and we say generate Java doc, then unless there's a mistake, here are all our different classes. There's something there's something I do need to do. Here in properties, documenting, I want to include private and package, blah, blah, blah. Class, include author and version, and then this will give me the title for my, let's try, and there were some, they've gotten kind of anal about, about this, so they're giving some warnings for places that they weren't. So where's our course? Here's our course. And here's the Java doc that I had for that. We list the constructors. Here's a list of the methods in the summary, but then these are all kind of linked. And so here, set number of days, parameters, and then throws. See, here's the throws that I had. And then I can actually do something like, let's see, is there? Notice, let's do that again. Here, since I was referring to another class that I was, in this case, the course one, so we generate it again, and here's I called it test course. Okay, testing the course component, but if I notice there, now this link is live, and if I click on that, that takes me to the Java doc for that. So what that allows you to do is that allows you to, if you're distributing this to someone and you don't want to let them have the source code, but just let them know how the thing works, they can see that. And it's basically a web page that documents your program. And I think that's pretty cool. Okay, so continue reading in chapter 6. And